In this tutorial, we will build a complete financial REST API with Python, Flask, and SQLite. We will write the code step by step, run the server, and test real API requests. You will see how a client request enters Flask, updates SQLite, and returns a JSON response. Postman will be our API client, but any web app, mobile app, or curl command can connect. The API will provide account, deposit, withdrawal, and transaction history endpoints. This demo uses one account and no login. Real financial systems require strong security. First, create a Python virtual environment to keep this project's dependencies isolated. Activate the virtual environment. The terminal prompt now begins with .venvib upgrade pip, so the environment uses the latest available Python package installer. Pip downloads the new version and replaces the older installation safely. Next, install Flask. Flask will receive requests and connect them to Python functions. Pip also installs Flask's required dependencies, including Werkzeug, Jinja, Click, and It's Dangerous. When installation finishes successfully, the project is ready to open in Visual Studio Code. The project contains the application code, the SQLite database, and the dependency file. The requirements file pins Flask to version 3.1.3 so the project can be installed consistently. Now create app.py. This file will contain the complete financial API. Import SQLite, decimal, and path, then import Flask's request and JSON helpers. Decimal provides accurate money calculations, while SQLite stores the account and transaction data. Create the Flask application and define the database file beside app.py. The demo account uses the ID ACC101. This keeps every endpoint focused on one account. The getDB function opens one SQLite connection for the current Flask request. Flask's G-object stores that connection, so the same request can reuse it efficiently. Row Factory makes each database row accessible by column name, which keeps the response code easy to read. Foreign key checking is enabled to protect the relationship between accounts and transactions. The teardown function closes the connection automatically after Flask finishes processing the request. Closing connections after every request prevents unnecessary database resources from remaining open. The initialization function creates the database schema when the application starts for the first time. Execute script lets us create multiple SQLite tables in one clear database operation. The accounts table stores the account ID, owner name, currency, and balance in cents. The account ID is the primary key and the required fields cannot be empty. The balance uses an integer number of cents and includes a check that prevents negative values. The transactions table records every deposit and withdrawal with an automatically generated ID. Each transaction stores its type, amount, resulting balance, and creation time. The foreign key connects each transaction to a valid account in the accounts table. Insert or ignore creates the demo account only once, even when the server restarts many times. The account belongs to Rainy Reeksme, uses USD, and starts with 100,000 cents. 100,000 cents equals $1,000. The database changes are then committed. The money to cents helper converts an incoming JSON amount into a safe integer number of cents. Decimal reads the value precisely and rounds it to 2 decimal places. Round half up gives familiar financial rounding when the amount contains more than 2 decimal places. The function rejects 0, negative, infinite, and invalid money values. A valid decimal amount is multiplied by 100 and returned as an integer. Invalid operation, type error, and value error are handled, so bad input returns a clean validation error. The format money helper converts stored cents back into a 2-decimal string for JSON responses. Account JSON converts a database row into a clear account response object. The account response includes ID, owner, currency, and the correctly formatted balance. Transaction JSON formats each transaction row for consistent API responses. It returns the type, amount, balance after the transaction, and the database creation time. The root get route confirms that the API is running and describes the available endpoints. JSONify converts the Python data into a valid JSON HTTP response. The endpoint map shows which URLs use GET and which operations require POST. GET requests read information. POST requests create a deposit or withdrawal transaction. The account endpoint selects the demo account using a parameterized SQL query. The question mark placeholder keeps values separate from SQL and avoids building the query with string concatenation. The selected row is serialized and returned with a success value of true. Save transaction is a reusable helper shared by both deposits and withdrawals. It inserts the account ID, transaction type, amount in cents, and resulting balance. Using one helper keeps the transaction writing logic consistent across both money operations. After inserting the row, the database transaction is committed permanently. The new row is selected with cursor .lastRowWith and returned for the API response. The deposit endpoint accepts a POST request at /API/deposit. It reads JSON safely and extracts the amount supplied by the client. The amount is converted to cents. Invalid input returns HTTP status 400. For a valid deposit, the current balance is loaded from the accounts table. The deposit amount is added to the stored balance to calculate the new balance. An update statement saves the new account balance using the demo account ID. The same deposit is recorded in transaction history with the updated balance. The API returns the created transaction, a success message, and HTTP status 201. The withdrawal endpoint follows the same structure but subtracts money from the account. It reads the JSON amount, converts it to cents, and validates the input. The current balance is selected before the withdrawal is approved. The requested amount is compared with the money currently available. If the withdrawal is larger than the balance, the API returns an insufficient balance error. This validation prevents the demo account from storing a negative balance. For an approved withdrawal, the amount is subtracted from the current balance. The updated balance is saved back into the accounts table. A withdrawal transaction is then recorded with the amount and new balance. The response returns the created transaction with HTTP status 201. The transaction's endpoint provides the complete history for the demo account. It selects transaction rows where the account ID matches ACC 1001. Order by ID descending places the newest transaction at the top. Fetch-all loads every matching row from the SQLite query result. Each row is serialized with transaction JSON before it is added to the response list. The response includes success, total count, and the complete transaction array. The application context initializes the database before the development server starts. When app.py runs directly, Flask starts with debug mode enabled. The completed source now contains all 4 routes and the database logic. Use the Flask routes command to verify every registered endpoint. The route table confirms the HTTP method and URL assigned to each Python function. Start the application with Python 3 app.py. Flask listens locally on port 5000. The development server is now available at HTTP 127.0.1 port 5000. Confirm that account, deposit, withdrawal, and transaction history routes are all listed. If an expected route is missing, save app.py and restart the Flask server. Open Postman and send a GET request to the root URL. The API returns its message and endpoint list. Get/API/account returns the owner, currency, and current account balance. Post a JSON amount to the deposit endpoint. The response confirms the new balance and transaction. Post an amount to the withdrawal endpoint. The balance is reduced and the withdrawal is recorded. Get the transactions endpoint to view deposits and withdrawals in newest first order. The complete flow now connects HTTP requests, Flask route functions, SQLite, and JSON responses. Money is handled with decimal for input and integer cents for safe database storage. Validation protects the balance, and every successful operation creates history. The database keeps account and transaction data available after the Flask server restarts. For production, add authentication, authorization, secure configuration, tests, logging, and monitoring. Build the project yourself and test both successful requests and validation errors. Changing one feature is a useful way to confirm that you understand the complete flow. You now have a complete working Flask Financial API that demonstrates real backend fundamentals.